I know that there are many listeners who are as fascinated as I am about what happens and what we know and don't know about what happens in space and deep space. We have known for some time that there is evidence of water frozen at the poles of Mars, and there is also evidence of vapor in the atmosphere. But now I believe we can believe with close to 100% certainty that there is a reservoir of liquid water on Mars. Not terribly easy to tap because it's quite a few kilometers underneath the surface. And to find out how we know this and what the implications are of this knowledge, we're joined via Zoom by lead scientist on the project which discovered this, Dr. Vashan Wright, a geophysicist at the University of California, San Diego. Vashan, good morning, your turn.
Good morning.
This is from a new analysis. The story that I read says a new analysis of data from the Mars InSight lander, which was sending data back between 2018 and the end of 2022. So what about the data? What kind of analysis did you do which makes you go, aha, there is water and liquid water, and it's about there?
Yeah, so the InSight mission, as you mentioned, was able to measure using a seismometer the speed of seismic waves and how they change with depth. Now, the speed of seismic wave depends on what the rock is made of, where it has cracks, and what fills those cracks. What we did was combine the measured speed of seismic waves and gravity measurements and this theoretical rock physics model. Rock physics models are the same ones we use to measure the properties of aquifers on Earth or map oil and gas. And what they do is they provide a connection between the speed of seismic waves and physical properties of rock. And when we search for the combinations of rock properties that best explain or observe data on Mars, we find that a mid-crust, so roughly 10 to 15 kilometers, whose rocks are cracked and filled with liquid water, is the thing that best explains our current data.
And was this a complete surprise, or did the evidence of frozen water at the Martian poles and the evidence of vapor in the atmosphere make scientists go, we're pretty certain there is liquid water somewhere. We've just got to find out where and go beyond we think to we know?
I'm not sure that scientists were certain that there is liquid water below the surface. I for sure was not in the camp of being certain that there is liquid water. We know that Mars once had water on its surface in rivers, lakes, and even possibly oceans. And we knew that liquid water being buried very deep in the subsurface was one possible solution to an age-old question of where Mars's ancient liquid water went. And so in some ways, because we knew it was a possible solution, it is not entirely out of scope, but I'm not sure we were sitting around, yeah, it has to be there. I don't think that was necessarily the case.
Okay, and now is there a theory as to how it got from, you say you knew that there were flowing rivers, there were oceans and so on. Is there a theory as to what drove it potentially 15 kilometers under the surface?
You know, the one of the things that became apparent is that the crust of Mars could have been filled with that liquid water in its early years. When we talk about rivers and lakes and possibly ocean, we're talking like 3 billion years ago. On Earth, what we know is that groundwater um, infiltrate underground from the surface, and we expect it to be similar to the history on Mars insofar as there's a connection between the surface water and the groundwater, whereby the surface water likely infiltrated the ground when a time when the upper crust of Mars was warm enough to allow surface water. So warmer than it is today.
And now that there is as close to scientific certainty as one gets that this liquid water is still there, or was there between 2018 and 2022. I mean, what options does that open up in terms of further understanding Mars's history and so on?
You know, what we've come to learn is that water influences just about everything about a planet's evolution, right? It affects the water cycle, it affects the climate, it shapes what the surface looks like, and it also determines whether or not the subsurface of a planet is potentially habitable, since water is a key ingredient for life as we know it. And so it influences a lot of those things, and there's a lot to learn. And what I would say about the scientific certainty here is that, we have one seismometer on the planet. We have the InSight data. We have the gravity data. And based on what we currently know, and based on what our models are doing and any assumptions in those models, this is the current best explanation for the data that we have.
Does what you know now tell us anything about what might happen to Earth? I mean, if water as an essential ingredient for life as we know it, but then maybe there are kinds of life that we can't conceive of that don't need water. As well, mysteries everywhere where you look, and I'm sure one of my listeners has just asked, where did the water come from? We now know where the water went and possible theory as to why it went there, but where did it come from? And so, I mean, there are a lot of it's intriguing, a lot of mysterious, there are lots of questions popping up here, there, and everywhere.
Yeah, and that's the beauty about the science, right? Working together in a community to find new questions when we have new observations or new analyses pointing to something that might have happened in the past, right? One of the things with Mars's water is that Mars once looked like Earth, as we establish, and now it doesn't. It's dry and it's desolate. And what happened was that Mars lost its stronger, stabler atmosphere. And that is likely related to losing protection from its magnetosphere. And so when that happened, the water on the surface of the planet was no longer protected. And so scientists are still trying to understand the real cause of the loss of water. An important component of that is where the water went. But to make a parallel to Earth, we'd have to be at a place potentially where we're losing our atmosphere, etc. And that would be pretty devastating.
Yeah, it certainly would. I hope it happens after I've kissed everybody goodbye. Thank you very, very much indeed. Dr. Vashan Wright is a geophysicist at the University of California, San Diego.